All right, Mr. Ahmed here for 3.3. Fairly short lesson today. This one is very similar to what we just did in 3.2. What we're going to look at, though, is the converses of the postulates and theorems that we just went over in 3.2. So in 3.2, we talked about if the lines are parallel, corresponding angles are congruent. So in the opposite manner, if we see corresponding angles that are congruent, then the lines are parallel. So since angle 2 is congruent to 6, those are corresponding angles. That means that line J has to be parallel to line K. All right, so that's the corresponding angles converse. In a similar manner, if two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. Our next one, if two lines are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. And finally, if two lines are cut by a transversal and the same side interior angles are supplementary, so not congruent, supplementary, then the lines are parallel. So we're really just doing the opposite. Instead of stating that the lines are parallel and the angles are congruent, we are looking to see if the angles are congruent. That would tell us that the lines are parallel. So the question states, based off what we see, are M and N parallel? Well, I guess they kind of look like it, but I don't know. There's no parallel sign here. These two angles are corresponding and they're not necessarily congruent. So as of now, no, they aren't. But is there a value of x that would make them parallel? Yes. If this angle is also 71 degrees, so if these two corresponding angles are congruent, that would make the lines parallel. So I need to set up an equation and say 71 has to equal 2x plus 3. If that happens, they will be parallel. So subtract 3, subtract 3. 68 equals 2x. X is equal to 34. So if x is equal to 34, then the lines are parallel because the corresponding angles would be congruent. So the postulate or theorem that we used is the corresponding angles converse, And if we put that in if-then form, I kind of like if-then form a little bit better, but the textbook doesn't use if-then form a lot. We would state if corresponding angles are congruent, then the lines are parallel, okay? So that would be how I could write it in if-then form. If we do a lot of proofs, we'll hit if-then form even more. This year we're not doing a ton of proofs based off the distance learning piece, but that's kind of the biggest benefit of the if-then. So next step says, are A and B parallel? Well, it says angle 1 is 40, angle 2 is 140. So 40, 140, those are same side interior. If the same side interior are supplementary, then the lines are parallel. So are A and B parallel? Yes. Why? If same side interior angles are supplementary, then the lines are parallel, which is the same side interior angles converse. So we use the converse of the theorem. And last one, are A and B parallel? As of now, no. Find the value of x that would make them parallel. So these are alternate interior angles. So if the alternate interior angles are congruent, then the lines will be parallel. So 5x minus 54 has to be equal to 3x plus 16. If that happens, they're parallel. So we got to solve this. Subtract 3x, subtract 3x, 2x minus 54 equals 16. Add our 54. 54 plus 16 is 70. And x is 35. So if x is 35, then the lines are parallel, okay? Postulate or theorem we used, they were alternate interior angles. So if alternate interior angles congruent, then the lines are parallel. I used the parallel symbol, okay? We also could have just called it the alternate interior angles converse. All right, that's all we got for today, so make sure you practice these ones up and have a good one.